Welcome to the Explainer. It's wild to pause and think about why we live exactly where we do, or how the invisible forces of birth, death, and migration are quite literally reshaping the world around us every single day. Today, we are going to unpack the fascinating mechanics of human populations. Let's dive right into how biological forces and human movement dictate the future of our societies. So here's our roadmap for today. We'll kick things off by counting the human race, then look at the biological human equation, tackle the aging population paradox, explore humans in constant motion, zoom in on Madrid's model as a case study, and finally map out the human blueprint. Let's get into it. Section 1. Counting the human race and gathering those demographics. Our main lens today is population geography. Basically, it's all about figuring out exactly how and why human societies are spread out across the globe the way they are. What is driving that distribution? And how does our population evolve when you factor in the resources we have? But to actually do this at a scale of literally billions of people, we need hard data. Enter demography. It's the statistical science of population size and structure. Geographers rely heavily on this demographic data to make sense of the human footprint. So where do we get all these numbers? Well, there are two heavy hitters here. First, we have the population census. Think of this as a massive official snapshot taken by the state every 10 years. It tracks the whole shebang: economic, social, and cultural data. Then, on the other side, we have the municipal register. This one is run locally by city councils, and unlike the census, it's a living, breathing, continuously updated list of residents. Combining that deep decennial dive of the census with the constant pulse of the local register gives us an incredibly clear picture of who is living where. Moving to Section 2, the biological human equation. We're talking births and deaths. All right, it all comes down to a deceptively simple number, 2.1. This is the synthetic fertility index, or basically 2.1 children per woman. Why 2.1? Well, it's the absolute baseline required to guarantee generational replacement. We could just look at the crude birth rate to count total births in a given year, sure, but the synthetic fertility index is the real deal. It measures the average number of children a woman has during her fertile years, showing us the true growth capacity of a society. Geographically speaking, without that magic 2.1, the younger crowd simply won't numerically replace the older generation. But hey, birth is just half of the story, right? To get the full biological equation, we have to weigh natality against mortality. This gives geographers what's known as the natural growth. Now, mortality obviously tracks deaths using the crude death rate, but it also closely looks at infant mortality, which, by the way, is a hugely accurate mirror of a country's healthcare development. So, you do the math. Subtract deaths from births. If births are higher, growth is positive. If deaths take the lead, you've got negative natural growth. Which leads us to Section 3, the aging population paradox, or the longevity paradox. Let's talk about life expectancy. The average years a person is expected to live from birth, assuming things stay relatively stable. Now, thanks to some massive leaps in public health, better nutrition, and advanced medicine over the last few decades, life expectancy in developed countries has absolutely skyrocketed. Places like Spain, and specifically Madrid, actually rank among the highest in the entire world. But here is the paradox. When you combine this amazing longevity with a continuous drop in birth rates, you get demographic aging. Basically, the over 65 crowd is expanding rapidly, taking up a much bigger slice of the population pie compared to kids and young adults. And, well, this structural shift puts a very real, very heavy strain on society. The socioeconomic consequences are impossible to ignore. First off, pension systems feel the squeeze because you have fewer workers trying to support a growing number of retirees. Then, naturally, there's a huge spike in the need for specialized health care for the elderly. Add it all up, and you're left with a shrinking percentage of working-age folks who actually generate the resources needed to keep the whole system afloat. It's a tough balancing act for sure. All right, Section 4, humans in constant motion. Let's look at spatial movements. Populations don't just change because people are born or pass away, they change because people move. Migration, the act of changing your habitual residence, is a huge piece of the puzzle. It breaks down into two distinct sides. You've got emigration, which is when people pack up and leave their home country or region, and then there's immigration, which is the arrival of folks into a new destination. Subtract the emigrants from the immigrants, and boom, you have your migratory balance. If more people are showing up than leaving, it's a positive balance. If they're packing up and heading out, it's negative. But why do people uproot their lives? Usually, it boils down to a few major drivers. Economics is the big one, people moving for better jobs or just an upgraded standard of living. But tragically, we also see political unrest and war forcing refugees to flee their homes. And increasingly, environmental factors like climate change and natural disasters are pushing people out. Now, when geographers want to find the true absolute population growth of a territory, they take that natural growth we talked about earlier and they add this migratory balance right on top of it. Let's put this into perspective. Section 5, Case Study, Madrid's Model. The community of Madrid is actually a textbook example of this equation in action. So, step 1. Just like the rest of Spain, Madrid is dealing with super low birth rates and an aging population. Biologically speaking, its natural growth is incredibly weak, sometimes even negative. But step 2, Madrid is an absolute powerhouse economically and politically. It's a magnet for jobs. Step 3, because of that massive pull, it draws in professionals from all over Spain and immigrants from abroad, resulting in a highly positive migratory balance. And finally, step 4, this constant influx does something amazing. It injects fresh, working-age people into the city, temporarily rejuvenating Madrid's workforce and acting like a buffer against the aging trend. It's a pretty fascinating cycle. Finally, Section 6, Mapping the Human Blueprint. Let's talk population density. We all know humans aren't spread out evenly across the globe. To actually measure this, geographers use population density. It's an indicator that simply looks at the number of people living in a specific place compared to the physical size of that territory, usually measured in square kilometers. It's a basic calculation, but it acts like a highlighter, showing us exactly where humanity is clustering together and where it is essentially a ghost town. Once you calculate that density, the world map basically splits into two extremes. On one hand, you have demographic voids. These are vast, quiet spaces where harsh physical factors make human life almost impossible. Think the freezing poles, scorching deserts, or towering mountain ranges. On the flip side, you have massive human concentrations. We're talking coastal areas, river valleys, and bustling urban hubs. And the reason is simple. These spots offer the fertile soil, fresh water, and abundant job opportunities that humans need to actually thrive. So, as we zoom out and look at all these deeply interconnected variables, from the 2.1 birth rate and aging societies to booming economic hubs and a shifting climate, it leaves us with one massive question about our future. The map, as we know, is never static. With populations aging out in developed centers and the environment reshaping our physical world, where will the next great human migration take us? Thanks for joining me on this explainer today, and keep questioning the map around you.